actually predominantly it's English, and the same with Qatar and some of the other countries. And what's not captured here is that there has been a great increase in the population over the past couple of decades, and also the urbanized population. So the cities have really boomed. And in the case of Qatar, for example, this is from, I think, 2013. So it actually doesn't capture the kind of boom that happened because of the World Cup. The FIFA World Cup really brought a lot of infrastructure in, a lot of people in from all over the world, and a lot of things that really were not there before, like the transportation system having that was built seemingly overnight, and functions very well. But so all of this, of course, is putting a strain on the water resources that were already quite stressed. So I like to just start with bottom line up front. So here's the overview of the challenge, summarizing it. The Gulf countries, and especially the GCC countries, face compounded risks from direct and indirect water security that stem from both the physical like scarcity, socioeconomic and political vulnerabilities. So I'll talk a little bit about all these different pieces. And then I also like to jump to the point. So jumping to the point, here's what I think, not just myself, but, proposed solution. So actually, in some ways, it's a region that's very complicated, of course, geopolitically and in other ways. But also, I think there are pretty elegant solutions that we are able to implement, partially also because of the governance structure of these countries as well, where decisions can get made actually in a very central way, and so funding can go behind these decisions if it's a priority. So actually, it's quite interesting because I think if there's enough impetus and interest and priority put behind an issue, there will be pathways to address that issue. And so, like, again, case in point of Qatar, they were able to really overnight, like, build all this infrastructure for athletics that they didn't have before, because it became a national priority to be a sports hub in the world, and FIFA World Cup being a good a good test bed for that, or bringing a lot of attention for that. Okay, so now proposed solution: reducing water demand through water smart policies and conservation awareness campaigns. As we'll talk about, there's a lot of, can I say water waste? There's a high water use in this region, and really a lack of awareness, oftentimes, from the local populations of where their water is coming from, or the degree to which this is different from other parts of the world. Increasing and diversifying the water supply with non-conventional water resources. We'll talk about that. So anything besides fresh water, meaning lakes, rivers, groundwater, right? Snow melts, right? Anything besides that is non-conventional. So desalination is considered a non-conventional water resource. And investing in research and development to decarbonize desalination and to reduce the environmental costs of brine. As we'll see, these countries are not going to be able to move away from desalination. It's not possible, given the where the demand and where the sources are. But there are, of course, ways that we can use technology and other means to make desalination more sustainable, more environmentally friendly as much as possible. Understanding and addressing the virtual water risks from agricultural imports. We'll talk about that a little bit more. And then, of course, we have an expert here on the kind of like geopolitics in the region, of course, around water and climate. It's a complicated region. So even within these, right, so the GCC is like an economic partnership between the countries, oil producing countries. Not everyone's in it, like Iran's not in there. Yemen is not in there. But so it's an economic interest, right? That's why they have the GCC collaboration. But at the same time, they're in competition with one another, and so they don't always work together. They don't always, cooperate or collaborate. And so I'll talk a little bit about that and kind of where I think Georgetown can help support. Maybe not solve the world's big, the regions, like all the regions' problems, but at least in part help support. Okay. So climate outlook, it's rough. It's hot, it's getting hotter, it's dry, it's getting drier, right? So this is the most extreme projection. I mean, of course, there's like to varying degrees that we may experience something like this, but already you have very high temperatures in the summers where it's really not livable. So you have to be very much indoors the entire time. So, if we had surface water resources, that would mean very high evapotranspiration. But in the case of groundwater, in the case of most of the GCC countries, they mainly have groundwater and limited surface water resources. But overall, this climate change, along with other things like urbanization, population growth, and ambitions, right, to be hubs in the world, to be more of a big player in the global stage, that's putting a lot more pressure on the water resources. And then I want to kind of talk about this classification of water. So if any hydrologists here, geographers, okay. Okay, so let's just talk about, like, we can break the water down into different components for the sake of this presentation and for communication purposes. So if you remember on the first slide, or the second slide, the problem statement, I talked about the direct and indirect water, right? So when we talk about direct water in the case of the GCC countries, that means water that's coming from groundwater predominantly, right? So that's the predominant source of water used in agriculture in GCC countries, because they mainly, with the exception of a couple, like countries like Oman and Kuwait, they don't have surface water resources or are very limited. Desalinated water, predominantly used for potable use and industry. Treated sewage effluent, or TSE, is an increasingly kind of viewed as an opportunity to be utilized, but right now it's actually quite untapped. So it's being mainly used for landscaping in the GCC countries, and the surface water quite limited. But the other piece of this is that because these countries are so water scarce, and because there's also very much of a lack of arable land, so on average, less than 5% of the land area is arable land in the GCC countries. So that means that you have a history of relying on agricultural imports, because most important user of water in the world, right, is agriculture sector. It's not humans, it's not industry, it's ag, because we need to eat. So there's this heavy reliance on what we call indirect or virtual water, which means all the water that goes into producing crops and other foods that are going to get exported from countries that are facing their own climate risks, their own geopolitical risks, and their own socioeconomic risks, right? So in this way, an importing country, or a country like X in GCC, is heavily dependent on, or actually is heavily vulnerable to the risks that are occurring in other countries, right? And especially those that are where they're importing from. And we'll talk about some examples of this. Okay, so just to drive it home again, an overall, going a little bit deeper into the water resources outlook of the GCC. So if you see in the bottom right figure, this is, you all know the World Resources Institute. Yeah, so they have developed this aqueduct tool that actually was developed for a very different purpose, initially for the private sector, for them to assess water risks, and then actually it turned out to be quite useful for a lot of people beyond that. So they produced this this kind of atlas state of the water security of the world every few years. And this just came out last year in 2023. I think just in December it came out. So it's no surprise, because actually it's the same thing that we had seen before, but 4 of the 6 most water scarce countries in the world come from the Gulf, namely from the GCC, right? So you have a real water limited countries, and the outlook is even worse. This is the most water stressed in the world. They rely heavily on desalination just because of their need. The Arabian Peninsula aquifer, that largely is actually like kind of over the Saudi Arabia, but is shared, is one of the most stressed in the world. And for example, Qatar extracts 4 to 5 times their renewable groundwater. And these numbers are a bit tricky, because actually we don't have really good assessments and good monitoring data on the groundwater and, for example, like monitoring who's using how much water. That's a gap that hopefully is going to be filled soon. And then they're, of course, very reliant and dependent on food imports. And there have been a lot of efforts in recent years to reduce this reliance and to actually be more self-reliant, self-sufficient when it comes to agricultural production. That's, of course, come at the cost of water resources, and especially on groundwater, leading to rapid depletion. But despite this, they're going to need to rely on agricultural imports. That's not something, I mean, if you like crunch the numbers, which many people have done, like in various studies, they still are going to need to rely heavily on imports, which means that they have to find ways to de-risk. They have to find ways to manage that risk of the indirect water, the water that's being imported into their country. Okay, so the first part of the solution, right, that I put on the one of the beginning slides was awareness and reducing demand, right? So this is not trivial. And you can see that for being the most water stressed part of the world, the GCC countries have a very high water use. And you can see on the bottom figure, you can see a comparison with other countries, with other kind of, industrialized countries, comparison of per year cubic meters per capita water use. It's very high in the GCC. And of course, yeah, again, on the figure on the top is just showing where the water scarcity is. So water use capita is just very, very high. And just to give you a sense of how little renewable water there is. Renewable water, so in this case, if you're relying mostly on groundwater, right, your groundwater can only get replenished through rainfall. And a characterization of a water scarce area is if you have around or less than 500 millimeters of rainfall per year. Yeah. So if you look at the GCC countries, taking Qatar, for example, they have less than 100 millimeters of rainfall per year. So it's really the kind of replenishment rate is extremely low. And then on top of that, an additional challenge that I think we largely attribute to climate change is that the rainfall that they do get is much more sporadic and kind of like, the same pattern that we've seen in other parts of the world, which is you get these really intense rainfall events and they're less predictable in short periods of time. So actually another big issue that I'm not going to cover is that that's led to significant problems with flooding. But think of it in terms of not like flooding in Bangladesh or Pakistan. Think of it in terms of like when we have snowstorms in DC. Yeah, it shuts everything down. It shuts down the city because it's not very frequent that we have these big snowstorms, right? So the city was not built to sustain that sort of events very often. Like the same amount of snow, let's say in Ontario, or in Chicago would be like not a big deal. Everything still functions. So in the case of the GCC countries and these cities, it's a similar thing, right? It's just, it doesn't happen frequently enough so far that they would want to invest super heavily in addressing the problem through like drainage systems and improvements, etc. So just I did want to note that that's a concern as well. And then again on the top right, we see the dependency, varying dependency on water imports and virtual water between the different countries, and the water consumption by different sectors in that bottom right figure for the GCC. And this is just for renewable water. It's not all water. But largely it's agriculture, right? Almost predominantly. And this is already a few years, let's see. Yeah, this is already a few years old. And actually these numbers have changed. So for example, in Qatar, that number is much higher now because they have really upped their agricultural production. And I'll talk about why that is in one moment. So this is a figure from the one of the ministries from Qatar showing the groundwater use. So that's what I said, actually. If you see the figure here for Qatar, it's about like 60% for agricultural water use, but it's actually much higher. This is from 2021. So you can see that most of the groundwater extraction is going for agriculture. And there's very little recharge from rainfall or artificially that's happening. But just one thing that's kind of interesting is that if you look at it's suspicious. If you look at the numbers, the official numbers for groundwater extraction for the country, it's steady state. It's like 100, 100, 100, 100. So the water balance doesn't quite work out. And I think it's because of in theory, replenishment through the injection of treated sewage effluent, but still those numbers are not really clear. So generally speaking, I think that there's one of the challenges is just lack of awareness of what the water balance is. So for the state of Qatar now, there's a study that basically a water balance study that's being undertaken by a few partners that are trying to quantify the entire water balance for all of Qatar. But interestingly, I mean, it's going to be difficult to do because they actually don't have the data. So even in terms of the groundwater data, that pretty much we need to rely on measurements on the ground or underground, right? There is no entity in the country that could take that on at the scale that it needs to be taken on. So again, there's a lot of opportunity for applied research for kind of this sort to really support the nation. And okay, so of course, what do you do when you don't have fresh water? Well, you over like 30, 40 years develop technology that can turn seawater into fresh water. And that's exactly what's been done. Saudi Arabia has kind of led the charge on the technology developments in many ways. But of course, I mean, desalination is not like the Gulf countries are not the only ones that rely on desalination for or that utilize desalination. Also in Spain, the US and Japan, other countries also use desalination as a means of complementing their water resources. But GCC countries by far dominate when it comes to desalination out of the need that they have. And if you look at on the right, recent publication showing the existing versus planned, future desalination capacity for the different countries, right? UAE and Saudi are really leading when it comes to their plans, and with the others kind of behind. And actually, it's interesting that Iran so not every GCC country is in here. We have Iran and Iraq also included. But yeah, so 40% of the world's desalinated water comes from the region. The water provides a large portion of the drinking water in these different countries. And so for example, in UAE, where it says 42% of the drinking water, so groundwater is also used to supplement the desalinated water for drinking as well. So it's not only for agriculture, but predominantly for agriculture. And as you know, desalination, no, it's Saudi. Yeah, I got cut off when I put it in. Yeah, Saudi Arabia. And of course, desalination, one of the arguments against it or the challenges that comes with it is that it is very energy dependent. So is, I mean, pumping for groundwater, but the energy intensiveness of desalination is much, much higher. But again, that's something that over the years, as our technologies have improved, the amount of energy needed to desalinate a unit of water has really gone down. And mainly that's been, so like there's kind of two categories of two methods, more or less for desalinating water. One is it's called the brute force, which means you evaporate, like you like just use a ton of energy to evaporate the and using evaporation to separate the fresh water from the brine in the salty water. But more recently, there's been more adoption of membrane-based technologies. So like reverse osmosis is something you may be familiar with. It's used a lot for actually not just desalination, it's used in for groundwater treatment as well. And so that just means that you have these membranes, and then you are forcing the salty water through these multiple membranes, and then it like by this force, it will separate the brine from the fresh water. So it uses much less energy than the brute force method. But the problem is that a lot of the older facilities in these countries still rely on the older method. And so they are still quite energy intensive, but many of them are, thinking about ways of reducing, of switching to membrane-based technologies. And most of the new facilities, desalination facilities, use that technology. And then the other problem with desalination is, of course, the byproduct, which is what we call brine. So it's that like salty minerally stuff that's left over once you separate the fresh water from the other stuff from the seawater. And so that largely, gets dumped back in. So it's maybe like treated just with primary, secondary treatment. And then it's dumped back in typically in the nearest body of water. So there are a lot of concerns about this dumping of this very highly saline water in high concentrations, right, in the near coast. Largely because of the impact that it would have on the coastal ecosystems, right? So causing, like reducing the oxygen levels in the water, that would impact a lot of the marine life. But that in particular, I would highlight as an area that's very understudied. I mean, there's like in looking through all of the research, generally we know that there are it's like kind of good and bad, not like it has negative impacts, but also maybe not so bad. I mean, it's really not clear actually the extent to which this brine and the way that countries are disposing of it is having an impact on the aquatic life. And then this second part of it is actually more of an economic argument, which also needs more research, actually, because it's a little bit light on the argument. But, if you're dumping this saline water back into the source that you're collecting your water from, that means that your source water is becoming more saline, which means that you need more energy and you need more money, right, to desalinate the same amount of water. So it's this like circular challenge that you have. And I can just jump to, talking a little bit about kind of forward thinking for the brine in particular. Right now, a lot of research is going into, can we commercialize the things that are in that brine, right? Like the different elements that are in that brine, can it be reused for, and I think I do have a slide on it, so I'll go to that in a minute. Yeah. But so definitely a lot of active research is going on how we can make desalination more sustainable and to really understanding all the environmental costs associated with it. Okay, now a quick example of just the extent to which this groundwater depletion is really a challenge. And we got kind of lucky in the case of Saudi Arabia because it's a large enough landmass and they have expanded just enough with their agriculture. And we have just enough satellite data that we can look at these things actually all together. So if you look at Saudi, right, in the 80s, they had these they had ambitions to become more self-reliant for the agriculture sector, for food security purposes. And so that meant really highly subsidized water for the ag sector, and really like anybody could get the water that they need. So you had this expansion of agriculture. And at one point in the late 80s, Saudi was a net exporter of wheat, which is if you know anything like about the water, I know you all know a lot. I shouldn't put it that way. Wheat uses a lot of water. So that it's quite water intensive. And so what we can see then, again, so this is from the GRACE satellite, it's a NASA satellite. It does not go back further than the date of which it was launched. Unfortunately, it can't hindcast, but we do from 2002 even, we can see this rapid reduction in groundwater, right? This it's quite amazing that we can actually pick this up because the satellite is quite coarse. Okay, and then, so I'm going to switch now. And if there are questions, please raise your hands. I'm going to go through it quickly. Yeah. Where? Here?
Yeah.
Oh, this is a study. This is a NASA study that's they're using satellite data. It's remotely sensed data. But how accurate are those data? I mean, it's accurate in giving us trends. It's not accurate in giving us exact numbers. Very shallow. I mean, so this is like shallow aquifers. It's basically measuring the surface deformation actually, and that's how it's measuring the groundwater changes, which is interesting. But yes, so it does not. Okay, tangent. So there was a group in Qatar that was trying to build a radar satellite, like a constellation that would get at the smaller aquifers in Qatar and elsewhere. And there were some questions as to like how valid that, how feasible that actually was, because it's really difficult to go below, like basically you can really look at very shallow aquifers. And in the case of like, let's say Qatar, they're much deeper. So it would be quite challenging to detect. No, this is not, this is what is GRACE? The gravity research, measurements, the surface deformation. Yeah.
So it's two satellites, and as they go over, based on the gravitational pull of the Earth, they're pulled more or less down. So what you're measuring is gravitational anomaly. So it's mass anomaly around the Earth. So it's doesn't really matter how deep it is. You're measuring like the total column mass of water anomaly.
And can you do that in other places where the aquifers are actually deeper?
Yeah, it does it all over the world. It's just very coarse spatial resolution.
Kilometers?
Oh, it's kilometers more. Yeah. It's extremely coarse. Yeah. So it's not something that you can use for like scenario planning for a country, right? It's something that can give you a so for example, when I showed the groundwater, like the Arabian Gulf, what was it called? The Arabian Aquifer. That's one of the most stressed in the world. So that comes from this satellite data. Basically, it looked at all the large aquifers globally, and then was able to look at how stressed they are to one another. I can do this now. I'll find this later, and there's actually like some cool animation I can show. I think this is it actually. You can't see this. Okay, now you can see it. Right. So you can this is from Grace as well. So you can even use it, right? So this is the scale at which we're looking at. You can also, it's been used for a lot of other things besides groundwater. So looking at like, I guess more or less wetness and drought conditions. Okay.
On that point.
Yeah.
What about marine groundwater? So looking at aquifers on the continental shelf, I know that there's a lot of increased interest in sort of sub-oceanic sediment freshwater deposits.
I have no idea. I don't think anyone's ever mentioned this, actually. I don't know if there's research being done, so I'd be curious if there is. I can see, I'm sure someone is working on it in the region. It just I haven't talked to them.
I know they recently discovered a large freshwater deposit off the coast of New England.
Interesting.
So that's an area where people are sort of thinking about.
That's so interesting. I mean, then that brings up like a whole other, I mean, if there is in theory, right, then that brings up a lot of geopolitical issues as well, right? Like who gets to tap into that? What could go wrong? Okay, so maybe we shouldn't talk about it. Maybe we shouldn't even bring it up. Let's not destroy everything. Okay, yeah.
So sorry to go back a little bit. I have a question that my students have been asking me.
Yeah.
Why can't you just dump the brine out in the sand, like in the desert? Why do you have to bring it
Well, that's not good for the desert habitat, is it?
There's a lot of desert.
No, there's life in the desert. I mean, actually, I will just say,
But there's more ocean than desert.
yeah, okay. I don't think that we should solve one environmental challenge by creating other environmental challenges as much as, I mean, we do this all the time, but as much as we can, right? We should, and you know, after being in Qatar for a bit, and especially during the winter when I could actually go outside, the desert is beautiful. It's amazing. Like it's really something that's I don't know if it's underappreciated. I don't think it's that actually, because the local population is appreciated very much. It's a place of recreation, just as the way we think about parks or forests here. Like it's a place of recreation. They go out, they have these, you know, like trailers and go out for the weekends. And they can only go out on the weekend. Like there's some, you know, regulation as to what you can do. So, you know, and it's also part of the culture too, coming from a nomadic peoples. And again, like in the case of Qatar, it wasn't that long ago that they were living at this nomadic life between the sea and the desert. So I don't know about that, but yeah, I hope we're not looking into that.
They also maintain a truck run is heavy.
Well,
That is what people say.
they have on the marine life. That's where I think the research is actually not super clear, because you have it's understudied. But actually, I have another argument for why you would not want to put the brine in the middle of the desert. I mean, in theory, without having looked into it at all, you would be increasing the desertification issue, or you would be increasing the what do you call it, like the sandstorms and dust that you get. So actually, like a big air pollution challenge in the region is from just sand, right? Like that's pollution as well. So I would say then if you have that coming into like the city and people are breathing it, you know, where chemicals have been added to it, I don't think that's a good solution either. But I like that they're thinking about it outside the box. Okay, I'm going to try to go a little bit more quickly through the next few slides. So just again, like stressing this point of how it is an indirect argument, right, for the water use. But if you look at the kind of vulnerability that comes with food imports, I'm going to use Qatar as an example here. So these are figures that I pulled, or like numbers that I pulled from the most recent exports, tomato and rice exports to Qatar, right? So largely you can see Iran is one of the big net exporters to the country for tomatoes, also Jordan, India, and a few other countries. And then India, Pakistan are India by far is the largest exporter of rice to Qatar. So on the figure on the right, then you can see if you start to look at these countries, they're also extremely water scarce. And not just water scarce, right? They're countries that are facing scarcity, droughts, floods, and politics. I mean, actually, like in Iran, the water scarcity has been so bad, and combined with kind of the management of the water, that there have been a lot of the cases of conflict in the region. Conflict meaning like small cases, right? Not like mass, like a war, but conflict, like protests and people being arrested, or people being killed, like individuals, right? That led to a lot of protests. Farmers were protesting. It was the first time ever they had seen farmers protesting, right? Like it was not political. It was just like absolutely environmental. So, you know, that's what we mean by this risk. And then, and so, okay, actually, I'm going to skip this one and go here. So in 2017, there was a blockade against Qatar. So the other GCC countries, plus a few others, created a blockade. We won't go into the reasons why, but they created a blockade against Qatar to try to pressure them into getting some things that they felt Qatar was doing wrong, getting some things changed. And so what that meant is that actually before 2017, a lot of the food imports, agricultural imports to Qatar came from the GCC countries. Actually, especially like dairy. A lot of their dairy came from Saudi. Dairy, milk, and the Qatari diets, and actually the diet in the region is quite dairy heavy. Yeah, So that led to this, two things, well, many things, but I'm just going to highlight two. So one is that actually before that time, there were tense relations between Qatar and Iran. And then because of what happened, it led to a normalizing of relations because Iran and Turkey kind of came to the rescue with increased imports of products, of agricultural and food products. And so that really was like what got them out of that situation in the immediate sense. And then they made significant changes to their food security policies. And so you can see that kind of reflected here in part, which is just going from 2017 to 2018. Number one thing is that they are now like, I mean, can I say fully self-reliant? No, but they're very, very close to being self-reliant when it comes to milk and dairy. And so that meant shipping 400,000 cows from Europe and the US to Qatar and really like creating a dairy sector that didn't really exist before, so that they were not dependent on especially on Saudi and the other countries in the region for that product. And then also there's been an increase in agriculture for other things as well. So a lot of hydroponic, not necessarily traditional agriculture, although you have that as well. But here on the right, you can see the number of farms. I think this is, yeah, it's a map showing cultivated areas in Qatar. I think there are 1,300 registered farms in Qatar. And not all of them are producing, so a lot of them are kind of smaller farms. But here's where the issue lies. Until more recently, when they are changing their policies around groundwater management, but basically all of those farms could just go and dig a well, right, and pretty much use all of the water that they needed would be coming from groundwater. So there was very little kind of, not even regulation, but actually checking that's, you know, even if there was a regulation, actually, you know, having some kind of a transparent way of monitoring. So that's created a really big challenge for them because, right, they solved one problem, but they created another one. Right? So they were able to, in part, like, and are continuing to try to address the food security risks and to de-risk their agriculture sector and their food security challenges, but it's coming at the cost of water resources, especially. And then I think this is, yeah, so might skip in this one too. This is not my area at all. We have experts here that do work on these topics, but I can't not mention it, that of course there are other challenges when it comes to water, and kind of conflict being one of them. Actually, a lot of the points that you see in and around Iran is what I mentioned to you, because of the droughts, and there were a lot of protests and kind of local conflict that came out because of that. So certainly a big risk as well when it comes to the kind of like greater reliance on water via agricultural imports. Okay, so now going back to the proposed, so a lot of challenges, right? The proposed solution, I already kind of talked about it. So essentially, you're not going to be able to get rid of desalination, right? So it is something that you can reduce demand. I think that's certainly a really important opportunity. But you're not going to be able to get rid of it altogether. So what you can do is to just make it as sustainable as possible. We already talked about a couple of, well, at least the brine issue, and then the using solar and other renewable energy for desalination rather than relying on oil and gas. There are a lot of challenges with the solar and other renewable energies, but I won't get into them now. And then the other is the sewage effluent, treated sewage effluent, right? It's wastewater. So and actually it's the only source of non-conventional water that increases with urbanization and increases with population growth. So it's kind of amazing. But it has an ick factor that a lot of people don't like, right? And especially I think it's interesting, and I've heard from kind of the argument, a bit of a religious arguments against like Islam is against water that's contaminated with especially this sort of contamination. But we looked into this a bit, and there really is not, that argument is actually not very strong, because I mean the water is treated, so it's I think it's just the ick factor that a lot of people don't like. So currently, right, there is a lot of untapped potential. You see these two figures, especially, and again, this is a little bit outdated now. Qatar now does treat a lot more of its TSE water, or does produce a lot more TSE water, but a little bit difficult maybe to see what's going on here. But I can just tell you that it's mainly used for like watering lawns, or it's dumped, you know, it's like used, maybe injected back into, you know, hopefully replenishing the groundwater, or it's dumped into kind of lagoons, or back into the sea. So it's not really used for agriculture, which actually a lot of other countries do use TSE water for agriculture. But it's interesting because the countries that they're importing food from are using TSE water in agriculture. So actually they are ingesting that water, right? But in the country itself, right, it's got, I think that's an untapped opportunity, let's say, to utilize the treated sewage effluent water more. And in Qatar, you know, for example, they treat the water, but they don't really use the water. That's kind of the summary of the challenge. Oh, and then just on the right, this is showing the fresh water utilized for agriculture, and then kind of showing, and it's again a few years old, but it's still more or less the trend holds that it's so underutilized, right? So the amount of the green is the reused wastewater versus the fresh water, which is essentially groundwater that's being used for the agriculture sector. Okay, now a little bit sci-fi, kind of, not really. This has actually been around for a very long time, right? The cloud seeding. It's that concept of you know, creating synthetic rainfall by manipulating the molecules and things in the atmosphere. So UAE has a program called the Rainfall Enhancement Program. That's really largely a research program. It was meant to be a means of, okay, so here's the challenge. Many challenges. Technologically, it's a challenge. We're not really sure if it works. It's hard to measure the effectiveness of this, actually, because you have to take very very complicated measurements. Remote sensing is a big part of it, right? And it's really hard to say, like, okay, is it, you know, is this actually the thing that led to the rain? But the other piece of it too is that there's a mistrust, right? Again, going back to the regional politics and the dynamics, even when I was in Doha in like November, there was a really heavy rainstorm that caused a ton of, I mean, it like shut the city down, right, for the day. And I heard a lot of, you know, I heard students and other people saying, oh, it was the UAE, like they cloud seeded. That's what caused this rain. It was, I mean, this one was easy because it actually wasn't, like, that wasn't the reason why. But there's a mistrust, right, in something like this of, well, you're going to use it for yourself, right? And you're going to take my rain clouds and use them for yourself, right? So interestingly, this what was meant to be a regional research program to bring everybody together has not really worked in that way. So it's I don't think a single person from Qatar is in this research group, and really it's been mainly UAE plus international partners. So I think it's an interesting concept, even just like, you know, other things, for example, of taking dew, like turning dew into fresh water. Okay, so now in like 2 minutes, 3 minutes, I will talk about what Georgetown is doing. And so the first thing that I want to talk about is a conference that we organized in November 2023. That was shortly before I actually joined this team. And you know, it was really interesting. I might just reflect. I don't need to talk about, okay, a lot of people came. We brought a lot of people together. Regionally, we really set our intention to focus on bringing local and regional people, experts, into dialogue with one another, and some international colleagues and partners as well. But you know, in a pretty short amount of time, what I found is that people were willing. If you went up to them and you were kind of like with good intention, you said, hey, we want you to come and participate. They were very much willing to come, which was really nice. And so we had very diverse perspectives from science, policy, geopolitics, and technology. And, you know, a lot of good kind of like dialogue came out of it. But the one thing that really stands out is that, you know, similar to the UAE example that I just gave, these forums are very difficult to form in a way that's actually productive and that the partners want to contribute to. So even when you talk about like technology, like tech exchange has been the easiest part. Like actually when we talk about, for example, desalination, there has been a lot of exchange among the countries when it comes to things like that. But when you start to talk about these bigger topics, the, you know, geopolitics and the broader risks, it gets a little bit more challenging. And I think that's where, you know, we as Georgetown can really help to facilitate that dialogue. And I do just want to say that this was super cool because it was joint between GUQ, Georgetown University in Qatar, the Earth Commons. We also had STIA, SFS from here that was engaged. We had Dr. Mark Giordano, we had Dr. Marcus King, we had Dean Mara, of course, that was involved, and Dr. Jamie Olson from GUQ, among others, that helped to organize this. And we brought 10 students competitively from this campus to the conference, and they participated, but they also helped us actually pull content together. And so that was really nice. And we had 10 students from the Georgetown University in Qatar that also participated. So that was, I think, the first time we've done something like this, but it worked really well. And it was, I think, a great experience for everybody. Oh, they also put on a great performance, so to speak, at the end of the conference in the closing, where that was joined with Derek Goldman's lab. So it was had a lot of things going on that worked very well. And then last thing, I will just go through some pictures, and I want to just share a class that I recently taught at GUQ called Water, Climate, and Urban Ecology. And you know, when I mentioned that there is such a lack of awareness of the water and environment issues in Qatar, I think from an educational perspective, that's a really good opportunity for, I mean, not just for us, for every university. So actually the class had a week immersion in Qatar where we went around, we visited where the water comes from. So actually all the TSE water and non-TSE water that's used for basically this place called Education City, where the Qatar campus sits, all comes from the mission control for water here. And there are green roofs in Qatar as well, which is interesting. Are they useful? Are they not? But we have some questions around that. There's some research that partners are doing on the effectiveness of green roofs in arid environments. Of course, sustainability issues concerned with all the big stadiums that were built during FIFA and since then. We visited one of the big farm. It's an organic farm in Qatar called Agrico, and looked at the, you know, different things that were mainly focusing on water use for the different crops. And then also there's in that central part, that's a nursery for mangroves, which is cool. So we also got to go out. So Qatar also has mangroves, which is amazing. This is a natural mangrove, and the students were doing some restoration work in this site. And finally, we visited a solar desalination plant. So this is an experimental, so this is an emerging area, basically. How useful, how effective can solar desalination be for small scale farming? So this is a small scale farm, and the colleagues at the Hamad bin Khalifa University are doing research, collaborating with the farm to test out this concept of a solar desal. And then we got to go to what's called a majlis, which is where you have dialogue over tea and coffee. And finally, we had a cultural component. And actually what is in this gentleman's hand, who's a great expert from Tunisia, is something called a desert rose, which is formed in the desert by salts and other kinds of minerals. And I thought about that when you said, actually, when the students of, I wonder if the brine can be used to synthetically make this desert rose things, because they're very popular as an aesthetic, right? Like you put it in your home. Okay, with that, I'm gonna stop talking and give at least a few minutes for questions. But this is the question that I posed to my students to develop a project around, which is, what is the sustainable and water smart arid city of the future? It's not an easy problem, right? It's not an easy question to solve. But that's I think what we need to do. Yes.
So to maybe like bounce off this question, I'd love to hear your thoughts on the line.
On the line?
The line, what
Of the
is it?
city?
Yeah, is that what we're calling it now? The line?
Yeah, it's-
Neom in Saudi?
Yeah.
Oh. I don't, okay, two things. Diplomatically, I don't know enough about it to have an opinion formed. Personally, I think that it's interesting in concept. I don't think it's I wouldn't consider that a city of the future. I mean, it's, I don't think that just as in the rest of the world, we've learned, we moved very far away from nature for a long time when we built our cities. And then we learned actually we need to move closer to nature and build with it rather than against it. I think that it's the same. It doesn't matter what ecosystem you're urbanizing in. It's the same fundamental thing, right? You have the same limits, the same planetary boundaries that you're dealing with. So what I would like to see and what I try to get my students to think about is not this is what AI generated when I put in like, what's the sustainable arid city of the future. This is not, I mean, it's like cool, I guess, but I mean, it would be wonderful to see, to actually have this one be a research topic that multiple people are working on. Two, to have something that's closer with the land, closer with the, the arid environment that you're living in. So that's why like things like, do we need green roofs? I don't know if that's the right, because then you need to water the green roofs, right? In that kind of environment. But yeah, NEOM, I mean, I think it's a really interesting test case for how we can build on the moon. Truly, I think from what I know, I think it's interesting because it's really like thinking about circularity and how to have a closed system. And I mean, that's the sort of thing that we need to like live on other planets that are extremely resource limited and the moon that are extremely resource limited, but we're not there yet on Earth. So I have a hard time with it, but it's interesting. Yeah. Yeah. And then,
Thank you so much for presentation here at the Arab Studies.
Oh, great.
Forest Service. So I think of these things through policy
Mhm.
and whatnot. And I want to ask, during this energy transition that we're seeing, and there was definitely a lot of talk a few years ago, at least, that the Gulf countries are considering like smaller budgets in the future. Are they taking that into account when they're considering sustainable practices in the future that might be less capital intensive?
So meaning
Smaller budgets in the future, talking, are they having that conversation? Or, that like desalination might be too expensive. And like there's different approaches.
I think maybe it depends on the country. So I mean, I'm not going to comment on it like I'm an expert, but just the little bit that I've seen and read, right? I think it depends on the country. If you look at Qatar, their natural gas reserves are abundant. So, I think, right, then it gets a little bit nuanced. Are we talking about natural gas? Are we talking about oil? And what will that transition be? I'm not an energy expert, so I think, I don't know exactly what that transition will look like. I think they are, and you can see it. I think they are, and maybe it hasn't hit home yet quite. You see it in the national, so all of these countries, or most of them, have national visions, 2030, right? So if you look at the national visions, right, they talk about diversifying the economy, and then some, in terms of like increasing the tech sector, increasing the private sector, like business, instead of relying on oil. I don't know. I don't know if it's, for my part or for our part, when we're looking into this, because one of the things we want to look into is this food, water, energy nexus. So when we look into that in terms of this virtual water and, like how much can you rely on agriculture and water use in your own country, I think that will be something for us to consider. What is the risk to not having the energy for desalination available in the future? And it's a bit tricky too, because the tech required or the energy required for desalination is going down, right? And the cost has gone down significantly. So it's going to be this balance between like tech and the energy transition that is very interesting. I'm sure people are looking into. I think you had a question.
There are some technologies where they capture water from the air.
Yeah.
And cheaper and less energy intensive, and but is the air in the Gulf region, is it like too dry to do that, or is there any like test case of that thing happening?
It's actually quite humid in parts of the Gulf, so not every place. Like yeah, it depends where you are. Yeah, there's research on this.
Is it scalable or not?
I haven't looked into it, like all the numbers. I don't think it's scalable on its own. And actually, I think it's quite expensive. I don't know if it's that, but it's just not something I've looked into much yet. But I think it's viable, especially when you look more forward at the non-conventional water resources. That's one of the areas that's being looked at. I don't think anybody in Qatar is looking at this, but UAE and Saudi have been a bit looking at it. The other thing is also just like actually the dew from AC units. That is one area that in Qatar they are looking at, and others. So I mean, it's actually significant if you think about like how hot it is and how much AC is running all the time everywhere. And so there's a lot of water leakage that can be captured and reused. So that's something that I think it's actually fairly easy to operationalize that, but they're looking into that from a research perspective too. Yeah. Sorry, one question back there.
Yeah, I just wanted to also echo, like, thank you so much. This was a wonderful presentation, but and you were commenting on desalinization. It's not a super research area, so maybe this question is unanswerable. But I was wondering if there had been anyone looking into non-potable uses for the brine that's produced by desalinization.
Yeah.
There's probably restrictions based on how salinated it is, but maybe like energy generation or something.
Yeah.
Or, like, yeah.
Absolutely. That's being looked into. So basically, this is actually a graphic I got from research that's being done at MIT. It's not even in the region. But that's being looked into, like ways of commercializing for things like, I mean, potentially for energy production or for other things. So that is an area. I mean, I think it makes sense. Then you can have true circularity. And I think the nice thing about this too, when we think of it as the greater commons, is that these countries do have more money to, in theory, if it is a priority to put towards R&D, which we may be limited in other parts of the world. So actually, even with also with desalination technology, that's advanced a lot because of the investment that was made in the region by Saudi and especially. So I think things like that are great because it can be, they can put more money into the R&D now, and it could be very useful for other countries. I'll just also mention that, other countries in the world that are facing water scarcity are also thinking about desalination at various scales. Maybe it's not going to be these massive, facilities, but small scale, like what I showed at the farm. Small scale is something that's being looked at. For example, Greece is one of the most water scarce countries in the world, actually, definitely in the region. And the islands are extremely water scarce. And so they're really dependent on imports. So that is something that a lot of them already have, small scale desalination. And so they're looking at ways of expanding that to meet their like future water scarcity challenges. So you know what I mean? Like it's great because if we think of it in this bigger way of, okay, research here can be useful in other places, then yeah, absolutely. The figuring out what to do with the brine is a really important environmental challenge. And it doesn't get enough attention. So like, it's good if you're interested in that topic to talk about it or to look into it. Yeah.
Sort of working off that,
Mm.
when you're talking about the scale of the desalination, you had the map of the conflicts. I was wondering like how fundamental water is to life and how vulnerable like how centralized is desalination in this region and how vulnerable are those facilities
Yeah.
being compromised?
That
like a tool.
absolutely. That's a concern. That's a really big concern, right? Because being compromised from a hacking, like hacking the system, these things are pretty tech forward, right? So you can, in theory, it could be compromised through by other countries, right? Or it could just be that you have some sort of a contamination issue that happens, right? So they're very vulnerable. Right now, the Qatar has 4 to 7 days of water reserves. which is, I mean, yeah, that's not a lot. So I mean, it technically could be more than that if you bring in some other factors, but they would be in bad shape, right? If one of the desalination plants was one of the big ones was compromised. So that's the sort of thing that, again, we as Georgetown can actually really help to think about these different scenarios of all the different risks that face these systems. That's I can only speak for Qatar because I don't know what the kind of national security priorities are, what's being looked at in the other GCC countries, but in Qatar, it's something that's actually not well quantified. And I mean, they have the water reserves that they have. Yeah, they've been trying to increase it. They went from like 3 days to close to 7, but it's a real vulnerability. Yeah.
Do they not have a lot of jellyfish?
Jellyfish?
Yeah.
I've never seen jellyfish.
6% of funding for jellyfish biologists is desalination plant issues. Yeah.
I mean, I've swam in the Gulf plenty of times. I've never, but it's kind of manicure. I don't know. I don't know what kind of environment do jellyfish live in.
Well, I know like desalination.
They like salty.
Jellyfish, in Israel, desal plants get clogged by jellyfish. And it's like why Israel's like one of the global epicenters of jellyfish science.
No one's ever brought this up, so I don't know, but I'm gonna look into it. Yeah.
Just importing.
I mean, just at the intake, you're talking about at the intake, it's being,
Yeah.
oh, it's like the birds getting hit by the propellers of, yeah, that's sad.
Okay,
I didn't know. Yeah.
Question. You talked about over protection. Is it really viable economically? Because you look at the growing season, you look at the temperature rise.
Yeah.
You look at even cattle growing in
Mhm.
expensive.
Yeah.
Would you do that when it's that temperatures are over 50?
Put them in AC.
Yeah, exactly.
Is it economically viable? Economics is not the biggest driver. National security is, right? Like, especially in this case, like the growth of the dairy sector. And I mean, that came after the blockade was a significant blow to Qatar. I mean, suddenly they were like extremely vulnerable, right? They were facing a food security crisis. So, I mean, it came out of that. It was not an issue of let's do the most cost-effective thing. It was an issue of we need to feed our people and not be vulnerable in the future, right? So I don't think it's actually, I do have statistics on that. I have tables and stuff that I can send it to you. Is absolutely not cost effective to grow anything in these, these kinds of environments. Yeah, I mean, and maybe with hydroponic systems, aquaponic, you have more opportunities there, but then you still have a reliance on water and you still need space. But yeah, it's not about money. I'll send them.
So this is less a question than a comment, but in Mexico City, we're about to run a water. Mexico City.
Yeah.
Cities. And quite limited, like that's one of the desal is not really an option there. Not an easy option. I haven't really thought about it. I don't know if people have a solution, but it's not Mexico City. Seems like it's hitting crisis stage.
Yeah.
Several situations like this happen. South Africa, Kingston, Jamaica.
Yeah.
Now Mexico City, where it's like hitting a crisis stage. There's no water. They're going into severe restrictions.
Mm-hmm.
Some other things too, like.
I think that's interesting too. So with Cape Town, that was they averted that crisis. It was largely a confluence of things like use, but also drought. And then they averted it by kind of having this Day Zero campaign that changed people's behavior. That's a lot of what that was actually. It was really getting kind of like what California did during the drought in like 2014, 15. I'm less familiar. All I know with Mexico City is that it was built in like the worst possible place. and it's like shrinking is what do you call it? No, it's a subsiding thing. Shrinking. It's subsiding at the same time as it's like in this valley, so it doesn't has a lot of water issues because of that. I suspect there's a lot of inefficiency in that system because it was also built a really long time ago. Like the groundwater network was built a long time ago. But what is the solution? I mean, I don't think it's going to be desalination. I don't think it's going to be pumping of water, meaning from one place to another. But potentially, I don't know. I'm not familiar with it, but I'd be interested to see.
Impact to the targeting desalination
Mhm.
infrastructure. We've already seen this happen a couple times, so it is like a very major issue of national security, both because water infrastructure is like an extremely detrimental and very effective hit of a target in terms of like the number of civilians that will be affected by it. And we've already seen 2008 and 2014, I think, the targeting of desalination sites in Gaza.
Sorry, was there a question in that? Or, I mean, yeah, especially if you look at the situation in Gaza, it's not something that's just happening now. It's happened over many, many years, right? Of water being used. And again, like Marcus, you can Dr. King can speak to this much better, but it's been used as a weapon, right? Like it's been used as a weapon in conflict, and now as a weapon in war. And so when you have, and this is the issue with any kind of, I mean, whether it's natural transboundary or unnatural transboundary, meaning like, you know, you have, let's say, water that's being treated in one place that needs to be like, you know, moved to another place, even if it's originating from that place, right? In the case of Sudan, you have like this issue with water where one has the treatment facilities and others where the water is actually coming from. You're extremely vulnerable. And yeah, I mean, it's really difficult to see. Again, I think that's where like the you know, I come from a solutions perspective because that's the world that I come from, of like how do we fix things. But in cases like this, it's much more complicated, right? Maybe it's self-sufficiency. Again, like in the case of Qatar, right? Like, does it make sense? No. Does it make economic sense? No. Does it make environmental sense? No. But they felt threatened, right? They saw this like vulnerability that they didn't think they had, or didn't realize the extent of it. And so then they took action, right? So what you, again, from a solutions perspective, what you hope to see is that after you have a shock like this, a significant event happen, that you build in a different way and that you change policies. But in the case of Gaza, I mean, there's so many issues on top of one another that water is just one of them, right? Water shortages, water being cut off, things like that. Yeah. But thank you. And I think we're a little over time, so.
Yeah.
Thanks.